In the nature, a system with more energy is less stable. In other words, the lowest energy state corresponds to the most stable state of the system. So, every system tends to attain stability by losing energy. Let's see how the atoms attain the lowest energy and tend to be in a stable state. We know that the nature is associated with innumerable chemical reactions. It is a known fact that an atom is the smallest particle that takes part in a chemical reaction. Hence, most of the elements exist in a combined state in the form of molecules. The few elements which exist independently are noble gases. This is attributed to the stable electronic configuration and the minimum energy they possess. Hence, the atoms of other elements which do not have stable electronic configuration and the minimum energy combine with other atoms of elements to form molecules. Thus, these atoms attain stability by the means of bond formation. The process of bond formation is associated with the lowering of energy of the system. The attractive force which holds various atoms together in a molecule is called a chemical bond. Kossel and Lewis made an attempt to explain the chemical bond formation in terms of electrons. According to them, noble gases are chemically inert because they have stable electronic configuration. The stable electronic configuration is due to the presence of either 8 electrons in the outermost shell, called octet configuration, or 2 electrons in the first shell, called duplate configuration. Hence, they exist independently in atomic state. On the contrary, the remaining elements having less than 8 electrons in the outermost shell are chemically reactive. Hence, they combine with other atoms of elements by means of chemical bonds so as to attain stable octet. So, they do not exist independently but exist in combined states as molecules. Thus, the Kossel-Lewis approach provides an explanation for the requisite of formation of bonds. Later in 1916, Kossel and Lewis developed the electronic theory of valence or theory of chemical bonding to explain the chemical bond formation between the two atoms. According to electronic theory of valence, every atom tries to attain octet in its valence shell by losing or gaining or by sharing of electrons. This is known as the octet rule. Only valence electrons are responsible for the formation of chemical bond. Except valence electrons, the remaining part of the atom, that is the nucleus, with the inner shell electrons, is called kernel. Lewis proposed simple notations to represent valence electrons in an atom. These notations are called Lewis symbols. As per Lewis symbols, the number of valence electrons of an element are represented as dots around the symbol. Let's look at the Lewis symbols of the elements lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine and neon as shown. The number of dots around the symbol gives the number of valence electrons. These valence electrons are useful to calculate the group valence of the element. The group valence of an element is equal to number of valence electrons of an element, or 8 minus the number of valence electrons. This is the significance of Lewis symbols. Now, let us look at the formation of ionic bond or electrovalent bond, which was explained by Kossel by considering the following facts. Halogens which are highly electronegative and alkali metals which are highly electropositive are separated by noble gases in the periodic table. Hence, halogens gain an electron, whereas alkali metals lose an electron to form negative and positive ions respectively. The positive ion and the negative ion thus formed attain octet configuration. The two oppositely charged ions approach each other and form an ionic bond or electrovalent bond. The electrostatic forces of attraction that holds the two oppositely charged ions together is known as the electrovalent bond. On the basis of these facts, let's explain the formation of sodium chloride. The electronic configuration of sodium is 2, 8, 1, whereas the electronic configuration of chlorine is 2, 8 and 7. When both sodium and chlorine combine together, sodium loses its one valence electron and forms positive ion, that is, sodium ion, whereas chlorine gains the one electron lost by sodium and forms the negative ion, that is, chloride ion. The sodium ion and the chloride ion attain the octet configuration of neon and argon respectively. These two oppositely charged ions approach each other and form sodium chloride. Due to the strong electrostatic forces of attraction between these oppositely charged ions, an ionic bond is said to be formed. Thus, sodium chloride is formed by the transfer of electrons from sodium to chlorine. The number of unit charges present on the ion is called electrovalence. In sodium chloride, sodium is assigned a positive electrovalence of 1, while chlorine is assigned a negative electrovalence of 1. Similarly, we can explain the formation of potassium chloride, calcium chloride, magnesium oxide, and other ionic compounds.